How's it going, everyone? Welcome to another video on the front-end system design. Euler Gonzalez here again, and in today's we're gonna take a look at what is this mutation observer in a more practical approach of how to use that and where are the most common use cases that a lot of company now use that, and also that developers instead of actually using some of this hacky stuff that we have to do back in the old days on the browser, the spec developers actually define now this particularly observer API to cover most of these common use cases. So for example, we have the intersector, we have the mutation and the resize that in case of the intersectors, it covers things like when you want to load some components here, so lazy loading components or dynamic UI elements, as well as virtualizations in for analytics. It's a way to see when these two elements intersect or when the user is navigating through your web page, how often is the user looking at that particular section or web page. That's actually useful. So as a way to get all of these metrics from that. So this is the intersection, what is the most common use case. And when it comes to the mutation, this is anytime you want to keep track of no mutations, how you can do that in an effective and efficient way. So you got now for rich text editors or drawings or rich text editors, for example, like Notion, that they're actually using is that. And the other is that, as I mentioned before, the drawing tools, right? And for the resize, which is something helpful, especially when you want to provide some graphics to users, let's say some finance, or to provide some data-rich interacting application, which is something that is moving forward. So a lot of these companies actually are moving forward to make all of this data, all of this, the backend, the data manipulations and treatments, parsing and analysis, how you can make and show something that is useful to the user in a way that is meaningful to them and they can actually make better decisions. That's part of the resize observer, that is to cover those particular business use cases. So for example, drawing tools or charting tools. So we're gonna make a quick recap of this particular course, which is taught by Yvonne Ray, a software engineer that has previously worked at JetBrains for over 3 years, and now he's currently at Meta. And thanks to him, he's now the staff UI engineering. So, and thanks to him, we're going to see is now the fundamentals that we need to know as a UI specialist to build these web complex applications. So whatever framework you're using behind the scenes, it's also important to not only understand what this framework does, right, but the underlying, the platform that all of this framework sits on top of that. So what does it mean is this is now the core structure for this, and we're gonna see that the introductions as a way to explain briefly is what an application, what are the several components of the applications, and then the core fundamentals, followed by the DOM API, and finally is get a more hands-on approach of these things called the web, of this of the mutation observer API. So let's get into this. So this as a way to getting to this particular course, which is layout in first understand the core fundamentals and how now the HTML and how now the browser treat HTML and how the formatting context is related to the stacking context and how that is in turn connected to the GPU and how the browser rendering that and how can we optimize is the rendering layer with in the composition layer and how can we use that to optimize that. And for that then we're going to look at the DOM API just most likely as a refresher. What are the most common things that we can, what is the structure of it, what is the value proposition of the DOM API, what is the structure, and what is the operation that we can do, right? Followed by the web API, especially the web to cover more complex UI patterns, all right, which is the focus of today's video, which is, well, the intersection of the observer API, the intersection, the mutation, and the resize. A more practical approach of actually building now that, for example, using the virtualization. And then we're going to see how we can now is look at the application state design, which is kernel state or memory, followed by the network. What are the particular protocols that we can use to do that, and the application performance, or in this case the asset management. So just as a ways to have things at most organized. Okay, so we have now this mental model here. First we need to understand is what is the core concept, the core fundamentals. So we looked at the browser after all, treat every HTML elements as by putting our box around it. When we talk about the design, the UI, and how now we look at the anatomy of the box and the property of the box, when you have the size and the types. So in the size you have is now inner or intrinsic values and the restricted value based on certain rules that you applied to that, as well as the type of boxes, which is the block and inline. And now as well as the anonymous, and how each one of those type of boxes like inline and block has its own mathematics and own rules that belongs to something called known as the formatting context. So this formatting context, where the key idea here is that it's able to isolate all of these elements, so rules from other external contexts are not affected. It is scalable because, well, you can not only use a block or inline, but you can also use some other formatting contexts like grid and flexbox, which makes them predictable. So each one of those particular contexts define a certain rules of how they must be work. So we also look at a couple examples of how can we define all of this formatting context, and then how the browser put all of these elements by following the normal flow. And when you change the normal flow, whether it's by using the position or the position relative or absolute, and when you change the normal flow of that, the relative and the absolute actually has its own particular rules that is going to be applied to, all right? Which means is that this position absolute, all right? Yep. That's right. So which means is that this position properties, whether it's relative and absolute, has its own particular rules. And now this is the way of how you can now is create is in stacking context. Okay, I get it. Okay. Yeah. Be here. And now this is how you can get it in a stacking context. All right. So this is stacking context, which is something that you tell the browser anytime you use is the position, absolute or relative, and also when you use 3D transformations. All right. So the browser is creating this stacking context, which is used not only for isolation, okay, of all of this set of elements that now the browser is going to put on the screen. All right. Formatting context is a way of how you can now isolate is the set of rules that these elements is a way of how you can isolate this set of elements that all outside context won't affect them, or outside scope won't affect them. And in the context of the stacking context is like how now these elements going to be positioned on the screen without other elements affect them. And by doing so, when we are defining each one of these particular contexts, all of these layers, all right, it is important to do it. It invites us to optimize, okay? That invite us to optimize is in terms. That invite us to optimize in terms of how this stacking contexts are going to be rendered, are going to be passed through the browser rendering mechanism. So what does it mean is that because the browser needs to render all of these elements, and if we're able to actually optimize that rendering mechanism, which is the critical rendering path, so by preventing a reflow, which is a particular stage of the rendering assembly line, the critical assembly line, the critical rendering path assembly line, when you have now this is the process of how the browser transform HTML, CSS, and JavaScript and other assets into pixel on the screen. So this is when it's created the DOM and the CSS object model merge into the render tree that contains all the necessary informations, but the browser doesn't know how to put those elements on the screen, how to position it and define the geometry. That's when the reflow happens, and this is usually happens anytime you modify the geometry or the position of an element, usually via JavaScript. That is triggering is that layout phase. So there are several CSS properties that allow you to avoid to mutate or to change the geometry or the position of the elements. So for example, CSS transform. So instead of actually change that, what it's doing is to now render is or it doesn't change the position of that. All right. It in fact is triggering is now the pane and the composite layer, only that. So the pane is, well, once the browser now actually put all of this data into bitmap representation here, then it needs to compose that, which is the final stage of putting all of this painted page, all of the part of the painted part of the page visible and group them. So group all of the different part of the page make it visible to the user. So compose it to the user. So the TLDR of this is that as we are able to describe what's happening there, and then we know what is the fundamental or the core fundamental here when you're describing this UI. Now it's time for us to create those UI. So we look at the DOM API, which is now this set of methods that allows to do that. Okay. Where now the DOM, as we can mention here, where now the DOM, again, is this set of methods that allow us to actually interact with this document representations. And usually, you do that, for example, when you want to create now low-level libraries, for example, in state management, like React or Redux or Angular or Vue, right? Or this virtualizations. Perhaps you want to create now components that needs to create a video tag or a charting engine, or you want to build a lightweight portfolio without minimal blueprints of any of this app, right? But the whole point of this is to understand now is the structure of the DOM. What are the global objects that you can use, and recognize that the DOM is not exclusively to JavaScript. You can use this now as a way to understand and have access to any other script language, for example, like Python, and then act upon that so you can build that. But in the case of this course, we're going to talk about is on JavaScript, which is what we care about. And after all, that's my specialty, JavaScript technology, JavaScript and TypeScript technology. Okay, so yeah, we look at this. Yes, we look at this DOM API, the global objects that you can have access to, the window, the document.body, the document.head, as well as the structure of this DOM, which start from the node abstract base class. Okay, and this node abstract base class act as a blueprint for other classes. So for example, like element, when you in element have several subtypes. So you have now HTML elements or SVG elements or any XML element as well. They now also act as a blueprint for the text node and for the something called HTML document that contain is this window object. And I think this is something important to be able to describe that, because it all starts with the node abstract base class. We are talking in the DOM. It all starts with the node for that. And how now the DOM node has, you can see here, there was DOM node, okay, NDM. Like this, right? And now how it is interesting because this belongs to the introduction to the DOM. Let me see here. And they also talk about is the abort controller. Interface represent a controller object that allows you to abort one or more web requests as and when desired. That's quite interesting. So when the fetch request is initialized, we pass the abort signal as an option. Okay, the new aborter, try this and the signal to the controller signal. Download complete. Process response further. And as the signal here, hey, you create a new abort controller, and then this controller is gonna have this signal. Returns an aborted signal object instant, which can be used to communicate with or to abort an asynchronous operation. If the request is aborted after fetch call can be fulfilled, but before the response body has been read, then attempting to read the response body will reject in an abort error exception. Running live example, simple offline development, video waiting download error, the operation was aborted. Download video, downloading occurring. Okay. Download error, video waiting, downloading occurring, downloading error. But this is something that you can use as a way to interesting, as a way to prevent these race conditions. What I'm doing here is a race condition. And there you got it. Simple copyright Blender Foundation.
What brings you to
that was quite interesting. Sintel or. Yep. But in any case, the thing here is that, as you can see here, right, from the DOM, the introduction of the DOM, which is a programming interface for web document, and it's quite important to actually describe this, right? What is the DOM? Right, it's this programmable interface for web documents. And it is also to understand this structure here. So accessing the DOM, fundamentals of the data type for that, document, node, elements, node list, attributes and node map, okay, and the DOM interface that you can have access, core interface in the DOM, all right. The following is a brief list of common API in web and XML page scripting using by the DOM. Right, it's like, hey, you can select that or add that, set the attributes, also listen to an event, window on load, setting text context as well, adding a child element as well, using the document object model. What does the document API do? As a way to exactly, so now understand this representation, all right, where now the node, which is this AstraB class, represent each one of them, right? So node, MDM here, part of the web API of the node. Here is an abstract class base upon which many other DOM API objects are based on, right? So we can safely assume that there is no such thing as plain node object. All objects that implements no functionality are based on its subclass. So in addition, every kind of DOM node is represented by an interface based on node. So it's like any of this node is represented by an interface of node. These include attributes, character data. As you can see, chart, character data, abstract interface represents a node object that contains characters. This is an abstract interface, meaning that there are any objects of type character. It is implemented by other interfaces like text, comment, citation, that kind of thing. So all of these abstract classes, they just act as a blueprint for that. They just act as a blueprint from that. So understanding now this structure here, right? And having a mental model of how you can do that, traversing HTML table with JavaScript DOM interface. And okay, this is now the structure of how you can traverse this. And locating DOM using selectors, all right? Something that we're going to talk about that later. And the introduction to the events as well. How white space is handling HTML and CSS. HTML largely ignore what's white space. Example of web and XML development using the DOM. Image attributes. Manipulating style. Using style sheets and event propagation. Example, we get computed style. Display event object property. The whole point of this, all right, is to understand that this is the base class. So this is the class that represents a node in the DOM tree, right? And this DOM tree is this data structure, it's a tree data structure that you can now that you can interact with this web page, right? So as a way to interact with this web page, we can use query data, adding or removing elements. So the most four common query operation that we can do is on the getElementById, which is quite straightforward. So getElementById, so the read cost and the memory cost for this is 0.1 because it's pretty much like accessing a hash, accessing a key on a hash map. Okay. Then you have now getElementByTagNames or names, where now this is getting you instead of an element, instead of this instance of that, pretty much like what it does, the getElementById. It's giving you a live collection, an HTML collection, which is a live collection, which means that is a reference from that. It's not a copy, okay? Which means that anytime we want is to, or anytime that reference is updated, when we modify that, it will affect in other elements as well. Not only that, but it will cause it will cause reflows from this. So if we want to take a look here at the HTML collection, right? which is a generic collection array like objects similar to arguments of elements in document order. An HTML collection is an HTML DOM is live. An HTML collection in the HTML DOM is live. It automatically updates when the underlying document is changed. For this reason, it is a good idea to make a copy from that. That's what happened. Hey, this provides you so the get elements by class name or tag name. They give you is now a live collection, right? So it automatically updates when underlying document is changed. So because now the way of how it's going to find that elements is based on this class or in this tag name. It will find them is by using the DFS, so the depth first search, right? It's gonna go through that, one of them, and the other is by looking is and when you find that, when the browser find that, you're gonna use some caching mechanism, some hash map, as a way to actually retrieve that anytime you actually get the same element. So you want to get that element that you previously get it, right? So the time complexity of this initially is linear time, but subsequent can be much more faster. Similar for the read cost, and the memory cost here is low because we are not actually copying any elements here, right? So because this is a live collection, all right, so this interface is called HTML collection for historical reasons, because before the model done, collections implementing this interface could only have HTML elements as their element. That's what happened. Okay. Collection, okay, because for historical reasons, because before the modern DOM, collections implementing this interface could only have HTML elements as their items. But now as the entire ecosystem evolve and move on, now they recognize that we are not only able to represent its HTML, we can represent its other collections as well, or other type of elements, SVG and that kind of thing. This interface was an attempt to create a modifying list. And only continues to be a modifiable list, and only continues to be supported to not break code that is already using it. Modern API represent list structure using type based on JavaScript array. Okay, again, again, because this was an attempt to create a modifying list. Today in modern API, the same use case are met by using array instance. Okay. But it's interesting. What is the problem they try to solve? You know? Why this in effect was an attempt to create a modifiable list? Why you want immutability? and only continues to be supportive to break. This historical reason do not mean that you as a developer should avoid HTML collection. You don't create HTML object yourself, but you get them from APIs such as document getElement by class name. And these API are not deprecated. However, be careful of semantic difference from a real array. It's interesting. Question. I want you to create me as an example here. Perplexity, please create me an example. Please generate an example of HTML collection manipulation of HTML collections where multiple functions or multiple events modifying DOM elements. As a software engineer with 7 years of experience, I want a practical approach to learn more about this, okay? To learn more about this, and it is trade-off. To illustrate the HTML collection in JavaScript, how multiple events can modify DOM elements, we can create a practical example here. So you have now all of it, right? Modify paragraphs, blah blah blah. In fact, let's go to Code Sandbox, right? So what to create here in the Code Sandbox is this one. But we're gonna take a look at the where in the F is this? Create a plane fragment morning. No, this is HTML collection example. All right, got it. Paste this, save this. All right. Okay. There's something called script XML, which is this. Select all paragraph element with the class text, and this will give you now is an HTML collection. Document getElement by ID, change text, and add an event. Click. Okay. So when you change that, I want you to run this callback, which is this array.from paragraph, okay? And when you have now this list of collections for each one of them, for the paragraph, you're gonna modify is the text context here. Event listener to change the text of all paragraph. Event listener to highlight all paragraph. Class list toggle highlight. I think you define some CSS for that highlight, exactly. Okay. So you need to transform this HTML collection. JavaScript function, selecting element, changing element, and highlight. Trade-off, live versus static collection. The HTML collection returning by methods like getElementByClassName is live. meaning any modifications to the DOM, like removing or adding paragraph, will affect this collection dynamically. This can lead to unexpected behavior if it is not managed carefully, especially in complex applications. Performance. Modifying multiple elements at once can be more efficient than updating them individually, especially in terms of rendering performance. Exactly. Modify multiple elements at once can be more efficient than updating them individually in terms of rendering performance. However, excessive DOM manipulation can lead to performance bottleneck if it is not handled properly. But look at this. Look at this. So now that we have this, right, and here we create now this script, but I don't want to define this script like so. In fact, I just want to say, hey, this is a single script. All right. I'm not going to define this as a type model. It's a single script. Okay. That what I want to do is this. Now that I have access to the document dot get elements by class name, I think it is, by class name, which is text, exactly, which is text here. What ended up happening here is to say, hey, give me this now as the paragraph, in plural. Okay, in plural, right? Paragraph. So now that I have this paragraph, which is a live collection, returns an HTML collection. See the HTML collection here. Okay. Since this returning is a live collection, and then you say, hey, I want you to know is on the change text. You say, hey, change text. So document get element by ID. All right. With that, okay, things started to make a lot of sense. Get element by ID here, which you say change text. All right. You say change text, and because this return is an element, and this element now has so it extends from the event. We can say, once you get this element, I want you to know access to the add event handler, add event listener, my bad, add event listener, okay, where now this is a function or a callback. It's a function here, right? Where I want now is to run this particular code here. So this is because I need to transform these collections as an array from, okay? You are doing is this. So what happened if you don't? Well, actually, you will have to because array from what is doing array dot from what is doing is to create is a new one. Method create a new shallow copy arrays instance. That's what happened. So what will happen if you don't use array.from to create a new paragraph, or to create a paragraph? Okay, well, what will happen if you don't use an array.from to create a new array and instead use the paragraph? Paragraph. To create a new array from HTML collection and indirectly use the HTML itself, you will encounter limitation to the nature of HTML collection. Here's what happened, not an array. An HTML collection is an array-like object, but does not have an array method such as for each, map, or filter. This means you cannot directly iterate over it using this method, which can limit your ability to manipulate the elements effectively. Iteration with for of. While you can iterate over HTML collection using a traditional for loops, for ops loop will not be able to utilize high order functions that are commonly used with arrays. Live collection. HTML collection is live, meaning it automatically updates when the DOM change. If you modify the DOM while iterating over the collection without converting to an array, you might run into an unexpected behavior such as skipping elements or encountering stale reference. So the idea of using here now is an array from. Okay, creating a new array because HTML collection interface. Okay. So HTML collection interface is limited when we need to when we need to mutate, when we need to interact or mutate elements. That's what we say, hey, array.from, or in this case array.from paragraph. No, I don't need, no. In this case, it's like, hey, transform this HTML collection in an array. Transform this HTML collection in an array. Okay? Transform this HTML collection in an array, where now I got all of this element. Where now I got all of these elements here, array.from. Static method create a new shallow copy array instance from an iterable. Okay. So here what you're telling is creating a new iterable collection here from this. And this is an static here. Okay, it's not per instance. Hey, I want you to create here now is okay. So when you say an array of this, for example, let's see if we can actually take a look at this. So when we say, hey, I want you to create now an array of this, it's like array, and you pass here, this just only is indicating is the length of that. No, this is indicating the length of that. And then what would you like to do this, right? From 3 to 4, right? But if you want to create now a new array, for example, from an iterable element, bro. So what you're doing is creating is a new copy of this, a shallow copy of this. You receive this element here, all right? You receive this paragraph as an HTML live collection. Interesting. And then you transform them into an array, so you can now iterate through each one of those. So for each of those elements, okay, where now the question is that what will be the type of this, which is an HTML collection, all right? That in return is the item and the name item, okay. The position of elements to be returned, and its return is a value, okay. Which a paragraph and an index, which is the element, okay. Which is a paragraph and an index. Where you are. Okay, which is the element. You return this, which is the element here, which is the element, which is the paragraph in singular, and the index. All right. And then what you're gonna do for each one of those elements there on the paragraph, which now you have a reference. Okay, since this is now a element, and this element is now extend from the node, and the node can have access to the text content, then you can say it's like, hey, this is a new paragraph here with the index, right? Modify paragraph here like so. All right. So this will work. There you got it. So this will work as expected. So for example, if I save this, all right, and then I say change text, why not? It doesn't change that. I'll write all of the paragraph. So for each is because it's for each, right? Oh, my bad. because it's like, okay, you're gonna react, but when, at which particular event? It's on the click, bro. Exactly, it's on the click. And when on click, this is what you're gonna do: array paragraph for each paragraph at the index, where you got now the element, and there you got it. Add event listener, get element by ID, add event listener, perhaps some. How can I look here at the console here? Oh, and they provide a live one? Interesting. It's not throwing any error. That's right, that's lovely. It fails silently. Get elements. Get elements by class name. I think it is. Get elements by class name. That's right. Get element by class name. Text, exactly. Get element by class name. You get all of this as an array. And then when you try to modify that, say, hey, document get element by that. So get me this particular element, and I'm going to attach now a callback. Whenever you click here, that is going to iterate through all of these elements, the paragraph, and for each one of those elements, I want you to now modify the text content. Add event listener. On click, you're gonna run this function, that is this. Oh, okay. Oh, it's because I'm not creating is okay. It's because I'm not creating is. It's because I'm not creating is. Yeah, I get it. It's because I'm not creating is this new instance here. That's what happened. And because I'm creating is this new instance, now it's gonna work as expected. And all of this is just as a way to work with these HTML collections in a more friendly way, in a more developer friendly way. Okay. All right. Okay. Modifying paragraph. And now when we, for example, document get element by the change text, and then click the event listener here. And when we say, hey, document, that's right, document get element by ID of the highlights, so say highlight, right? And once I get this element, which is what is going to return this query element, you say, hey, you know what? I want now to add an event listener that when you click here, on click, all right, I want you to run this callback. So in this case, it's just like highlight that. So by adding is this style here to all of this text, right? Putting it as yellow. Now put it then as, let's say, background color yellow. Okay, background color yellow. Yeah. So what I'm gonna do is to actually get all of this paragraph and apply now that. So we're gonna create now again is a new set of paragraph that for each one of those elements, okay, for the paragraph followed by the index, or in this case only the paragraph, right? We say, hey, for each one of those elements that you're doing here, and it is interesting, this actually works because we are creating is a copy of this, and since we are creating is a shallow copy, which this shallow copy now has reference, so we are mutating is the reference of that. What happened is that we are mutating is the reference for that. What happened is that we are mutating is the reference from that. So we are mutating each one of those reference for that. Okay, that's not a good sign. You say paragraph, but in plural is a paragraph. Since now this paragraph contains an element, and if you take a look at the element in MDN docs here, okay, and as you can see, the element has attribute child list, class list, okay, but this is read only. Inner HTML, outer HTML, scroll. How you can now add is or replace is that. A string representing the class element there, what a class is. Return a DOM token list containing a list of class attributes. So for example, if you say class list, okay, where this class list allows you to add, or exactly, class list, let me add this, but this is come from the element, exactly, this come from the elements. Add list here, for example here, paragraph, you say, hey, create a class list that contains now properties where you can add here when you say, hey, I want you to now add this, or toggle, exactly, or toggle to that, or toggle the of the highlight, right? So when you save this, exactly, on toggle that, you're gonna do this, which is great. So the whole point of this is to recognize that at the end of the day, what you're doing is to modifying is the elements in each one of them. So we can do something like this as a way to see this one by one. How so? By saying it's like, hey, set set interval of 2 seconds, okay? Where I want you to now run is this one. Right? So when I do this, oh, it modified all of them? I'm inside of these for loops, it run this, of course, it makes sense, it makes sense. It modifying all of this at that because you call this method all of it, and then it's gonna do that. So we're gonna do that one by one, okay? We will need to say, hey, okay. You can say is now this is the index. Multiply or add a 1 and then multiply that by 1000. So the first time it'll be 1 second, and then the second one it'll be that kind of thing. Okay, it's because it's running all of this. Set interval or set timeout. Exactly, it's going to trigger all of this at once. Yeah, but the whole point of this is to say, oh, I will need to wrap this. Yeah, I will need to wrap this functionality inside of this. Yeah. I will need to wrap this functionality inside of this. So now exactly. So I will need to wrap this functionality is here. So I'm saying here. Exactly. So I'm saying here is that, hey, anytime you're gonna run this, I want you to now pass this to the callback queue and say, hey, let's going to evaluate this after 2 seconds. And this one exactly after 2 seconds, right? And then he's going to, now after 2 seconds, going to evaluate that one. Just oh, here we go. Here we go with this closure shit. Hmm. Yeah, but the thing here is that you are mutating elements is individually, right? That's what happened. Um, Changing, exactly. Mutating elements individually are not efficient. That's one of the reasons that I say it's like, yeah, it's not efficient because you are first because you're working with live and static collections, and also is that performance consideration. So trade-off. Trade-off. Yeah, the trade-off of this is that exactly. So the trade-off of this, okay, is that one, life versus non-life. Yeah, life versus non-life. So working with the life collection can lead to unstable states in your DOM when multiple elements, with multiple events modifying the DOM. And the other is that performance. It is much more faster, it is much more faster to by chunks, bro. Yeah, it is much more faster to update the DOM by chunks of elements rather than by chunk of elements rather it is much more faster to update the DOM by chunks of elements instead of individually instead of individually completely because you are now mutating is another object, therefore triggering is reflow, therefore triggering is reflow on each update. That's quite interesting. That's a very simple example, very silly example. Silly example, but good enough. Good enough, bro. Okay. Mm, 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 mm. And also because you are now holding, because you are creating, this is interesting, because you are creating a shallow copy, which is a reference, okay, of all of these elements. But nested reference are mutating the original object, okay. Mhm. 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 And it's also not that convenient to work with. It is not that convenient to work with. It is not that convenient to work with. Mm. Mhm. Well, that'll be all for this video. Take care. Bye bye.